lesson number 13, we are going to start with first discussing about the different types of converters. So the first half of converters we have already covered, that is fully controlled converter. Its other name is full converter or full wave fully controlled rectifier, or it is also called as two quadrant converter. Now let us see why it is called as two quadrant converter. So over here, if we plot V out versus I out, and we are talking about two quadrant converter. This is nothing but a full converter, right? Here, output may go to positive value, but current will remain always positive throughout because of unidirectional nature of the current flow in a SCR. So in this case your power will be positive, and in this case your power will be negative. All right. Now, particularly, I'll give you one more detail. This case happens for alpha less than 90 degrees. You have seen that why. So over here, the power is being transferred from source to load when the power is positive. When the power is negative, this is the case for firing angle greater than 90 degrees. And in this case, if it is the RLE load and E is connected negative, your power is transferred from the load back to the source. Power being negative. Okay, this is very, very important, the concept of two quadrant converter. That means output can go negative, average value of output can go negative, average value of output can go positive also. Is that clear? Now this is nothing but the full converter. We have already covered with R load, RL load, continuous, discontinuous mode, freewheeling diode, without freewheeling diode. Correct? So from today onwards, we will start with converter. What is the specialty about full converter? Entire cycle is utilized, positive and negative, and using 4 SCRs. Right? Second, we are going to start with one quadrant, or it is called as semi-converter. So in semi-converter, we have two diodes, power diodes. Whenever I say diode, it means power diode in power electronics, and two SCRs. Fine. And over here, the power will only be positive, and the voltage also will be positive only. It will never go negative. Here, power is always positive. Whether you take it alpha greater than 90 or less than 90, it doesn't matter. It will always be positive, right? So let's start discussion of semi-converters. I guess I have already written down single phase semi-converter with R load. So even if we are missed in between full converter with R load, RL load and RLE load, no problem. This is slightly different topic. Pay attention now. I'll go slow with the first one. Okay. So here also there are two configurations. One is symmetric configuration and other is asymmetric configuration. There is a difference between them also, not just structural difference, but also there is a difference in the average SCR. We have first drawing symmetric configuration. Over here, when you draw a semi-converter, first of all, draw a bridge like this and connect them together. In case of a semi-converter, if the SCRs are placed in different legs like this and the other ones are diode, this becomes a semi-converter. Now we have a resistive load, right? Okay, positive, negative, V out, and we have a resistive load. Let us naming convention also be together. This is T1, alternate this will be D1, diode, this will be T2 and this will be D2. Easier to remember, Positive half cycle, T1 and D1 are on. Negative half cycle, T2 and D2 are on. Okay. And how will you connect the input supply? This leg will go over here and another one will go over here. It's very important to connect the input properly. There are marks for drawing the circuit diagram also. The circuit diagram waveform should be without any mistake. This is positive, this is negative. And if a current flows in a circuit, how it will flow? I out is the load current or output current. I in is the source current or input current. Is that clear? Now how this will operate? So we have to see this working of this in tandem with the waveforms. Now, out of this SCR, which are the SCRs? T1 and T2. How do you say? Because of the symbol of SCR. Now, how does the SCR turn on? Are they controlled? Can we control the SCR? Yes, they are controlled. They can be controlled. What can we control? We can control turn on. We can control turn on of SCR. How we turn on the SCR? There are two conditions. First, make it forward bias or in the forward blocking mode. Second, you apply the gate trigger to its gate terminal, then the SCR will turn on. Right? Now, this is about the SCR. What about the diode? When I talk about the diode, it means power diode. So D1 and D2. Are they controlled? Can they be controlled? Do we decide when they turn on or we decide when they turn off? No. Positive half cycle turns on, negative half cycle it's switches. So these are uncontrolled devices. Uncontrolled means there is no control over its turn on and turn off. समझ में आया? So we have a controlled SCRs along with uncontrolled diodes. Now we have to establish how this will work. For that we have to apply input, AC input, and these are the waveforms. So let's start our discussion. So please start with your, when we draw, immediately draw V in and IG quickly. V in and IG, you should draw it very, very quickly. Okay, this will be IG1, right? This will be correct. Again IG1 and IG2. Okay, so I have to plot I out, V out, and I in. These things I will only concentrate on. Have you drawn this V in supply and gate current? So alpha is my firing angle. After a delay of pi, I'll apply the firing angle again, pi plus alpha. It's very important, it should be synchronized. If it is not synchronized, what will happen? You will get asymmetric peaks. PM tak nahi jayega. You must have observed in your lab also while doing the practical. Okay? Can we begin with the explanation? Yeah? Let me check if I have explained the various cases over here. Yeah, I have explained. So can we start? Okay. Now, what happens between 0 to alpha? 0 to alpha, which of these devices are on? So which is on? D1 turns on. You have positive, negative here. So D1 will turn on. T1 is eligible to turn on, but it is off. बराबर है? So T2 and D2 question ही नहीं है. T2 and D2 will only turn on, eligible to turn on during reverse bias, during the negative half cycle. So right now from 0 to alpha, what is the state of event? Which is on? It's on. But again, it should be on pairing. the forward blocking mode, but again it is off. And T2, T2 are off only. They will get opportunity to turn on during negative half cycle. So what about the now everything is off? Built up by I out current. No. I out current will be zero. What about V out? Current is zero है तो current into resistance also will be zero. That will be zero. What about I in zero? So please draw it over here. From 0 to alpha, I out will be 0. Let me use a red color. Okay. V out also will be 0. And I in also will be 0. So far so good. So actually this is the picture. Whatever na? T1 is off, T2 is off, T2 is off, only T1 is off. But disconnectivity ho gaya na off water. If it is off, SCR is off, that means it is behaving as an open circuit. So no input current will flow, no output current will flow, output will be 0. Clear it is? Now, what happens between alpha to pi? Now we have applied the trigger. So T1, which is in the forward blocking mode, it will turn on. T1 will turn on now. T1 is on only, right? Positive half cycle. What about T2 and T2? They are off. So will the current flow? Will the current flow? Yes. Will there be a voltage? Yes. The voltage will follow the input. Now I will show you that circuit. समझ आइए? T1 is on, D1 is on. And how will the current flow? I have marked A, B, C, D also. So how will the current flow? Ion flow. A, then T1, C, R load, D, D1, back to B. This will be the part of current. Right? So current will start flowing and output will be equal to the. Why? Because if SCRs are turned on, they'll behave as a short switch. So directly your input will be connected to the load via SCRs T1 and D1. Via SCR D1 and diode D1. Is this clear? So how will you draw this? I out waveform will be, what about I out? I out will be V out upon R. V out is Vm. So first of all we'll draw V out. So V out will be equal to V in till pi. ये pi है, this is pi. What about I out? I out will follow the same nature. But here, what is this? Vm. But what will be this? Understanding? Vm upon R. What about input current? Input current nature will be same. Yes. Your I out will be equal to I in. It will be same. From alpha to pi, is it? Have any doubt? All your natures will be same. Any doubt in this? Can we proceed forward? Okay, fine. Now we have come to the next case. Let me change the color to blue. Now we are going from pi. Listen carefully, and this is important. Once one cycle completes, then it's easy. Now pi to pi plus alpha. Alpha is the firing angle, right? This period after pi. So after pi, something interesting is happening. Your V in is going negative. V in is in a negative half cycle. So whenever V in goes in a negative half cycle, what it will do? First of all, it will turn on. Here go. V in is in a negative half cycle. So अगर V negative half cycle में है, let me try to ऐसे हो गया ना? It will reverse bias T1 and D1. T1 to off ही हो जाएगा. T1 also will be off by land capacity. Reverse voltage आ गया ना? So T1 and D1 will be off. Which will be on? T2 will be on and T2 will be eligible to turn on, but on नहीं हुआ है. Forward blocking mode में. मतलब in the entire circuit from pi to pi which is on? T2. T2 is on. Rest everything is off. Correct. अगर T2 on है, there is a current flow because you require pair. T2 and T2 का pair to turn on together. So in this case, again, I out will be 0, V out will be 0, IN will be 0. So same as the first case of 0 to 12. Okay. So over here, what will happen? Your I out will be 0, V out will be 0. Right? So I'll show you the situation. ऐसे हो जाएगा. देखो इधर ध्यान से देखो. When we apply, yeah, what I said just now, it is available over here. So because of the reverse bias, what will happen? T1 जो on था, that will be this line voltage will come across T1. See, positive, negative. It will reverse bias it. Reverse bias मतलब T1 is going in the reverse blocking mode. What about D1? D1 also reverse bias, right? T2 भी off है. Why off? Because trigger pulse नहीं है अभी तक. D2 is only on. So if D2 is only on, your I out will be 0, IN will be 0, V out will be 0. Are you following? So what do you say? T1 is turning off by line commutation or natural commutation. Line voltage reverse आ रहा है उसके across, तो off हो गया. Diode is turning off because as soon as Vin goes negative, diode off हो गया without your control. Okay. Now let us come to next case. You're following? So yeah, we have to transfer that information. So from pi to pi plus alpha, I out will be 0, V out will be 0, IN also will be 0. Yeah. Now, next case, pi plus alpha to 2 pi. Now what happens? Yeah, you enter a negative half cycle completely. Abhi T1, T2 is turned on. T2 to on ही है पहले से. T1 and T1 are off, right? So what will happen now? What will happen? T2 on है because you applied the trigger pulse. T2 is also on. So now how will the picture will be? Let me draw it and my T1 which is off. T1 T1 T2 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 are on means short circuit, off मतलब open circuit. And here we have V out. Okay. That is my input. Input is over here. It is connected over here. देखो यहाँ पे connected. What is the polarity of the input? Positive या negative? यहाँ पे positive या negative? Now tell me what the current IN will, but IN will not go in this direction. In which direction IN will flow? Now, if this is point A, this is B, this is C, D. So how will the current flow? D. T2 point C, R low, D, I mean, sorry, D, point D, then diode D2 and back to supply D. Current is going in this direction, but the load current is in the same direction. But ये change हो गया, ion का direction change हो गया. Earlier it was going from A, D1. Now it has changed the direction. मतलब if I out it will be same as I, but not in magnitude. Magnitude same, but polarity will be different. ठीक है? What about V out? Is V out equal to V? It is equal to minus V. Why? अच्छा देखो 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 इधर देखो ये पॉजिटिव पोलैरिटी है पॉजिटिव पोलैरिटी इज कमिंग ओवर हियर एंड दिस इज नेगेटिव पोलैरिटी कमिंग ओवर हियर दिस इज नेगेटिव पोलैरिटी राइट so actually output जो है input is going negative half cycle right It is following negative half cycle, but polarity of the output is positive. Why output is positive? Because I out का direction change नहीं हुआ है. I out is still flowing in the same direction. अगर I out का direction change होता, then V out would have been negative. But now in the negative cycle, we are getting positive output. So that means output is following negative of V. मतलब, I'll show you over here. If we are going in a negative half cycle, still output is positive. Output ऐसे ही है, let's say. So what do you say? This is negative. This is V, right? Negative of V, positive one. What is this? What is this dotted line? Dotted line is minus V. I can say output is following minus of V, not V. अगर V follow करता तो नीचे होता. That's why over here, how will be my output? That's why we say V out follows minus V. Negative of V, not V. Now, how will be my output looking like? Over here. Yeah. Tell me. It will follow minus V. ये minus V वाला line. Like this. And then the cycle will repeat itself. From 2 pi to 2 pi plus alpha, again everything will be off. And then it will keep on repeating. Are you following? Same thing will happen over here also. Current also will be positive only throughout. So please complete the waveforms now. And what about I in? Chalo, I in batao. I in over here is minus, right? So how will you show it? It will follow. Samjha? Is this clear? So these are the waveforms. Okay. So from alpha to pi, which transistors are on? I mean, which SCR is on? T1 and D1 is on. From pi plus alpha to 2 pi plus alpha, what all things are on? T2 and D2, and again the cycle will repeat. T1, D1. So this is how it operates, semi-converter. Any doubts in this? Please note down the waveforms fast. Sorry? IAG. Have you drawn it? And please, whenever you draw it one below the other, all the dotted lines should be visible to you only. It's just for reference. You don't draw dotted line very dark, very light. That is just for reference. So that the actual waveform shape will be proper. Or else positive half cycle will be very long and negative half cycle will be very short. It should be equal. It's a periodic waveform. Any doubt in understanding? The single phase semi-converter with resistive load, very, very simple. No challenge at all. And from here on, your cycle will repeat itself. Now we have to derive the output average voltage value expression, right? Derivation for V out average. Here it is. Okay. Now, just to save time, you all can directly write the result. Fine. Just have a look at it once, please. I hope you have completed the waveforms. This is how the waveform looks like output. Please listen. So what is the period? Over here the period is 0 to pi. Why? Why not it is 0 to 2 pi? Because the period is something which it repeats itself. And from 0 to pi, after pi to 2 pi, it's repeating itself. Hence the period is pi. And what is V? Vm sin omega t. So output V out average will be 1 upon t integral 0 to t Vm sin omega t d omega t. Right? So Vm will come out. Integral of sine is minus cos. And cos pi is actually minus 1. So if you solve this, you will get V out average as Vm upon pi 1 plus cos alpha. Write it down. V out average is Vm upon pi into 1 plus cos alpha. This will be used in your practicals also. But alpha is the firing angle. for semi-converter. What is I out average? V out average upon R. Completed? Yeah. Now similarly we'll calculate V out RMS. Written the formula Vm upon pi into 1 plus cos alpha. You're writing? Write it down. Huh? Acha. V out RMS, just quickly go through the derivation. T is pi, V in is Vm sin omega t. So what is the definition? 1 upon d, 0 to t, V in square d omega t. The whole raised to half. So again V in is Vm sin omega t. So Vm square will come out. Sin square omega t is 1 minus cos 2 omega t. It will come out of the integral. This 1 will become omega t. And cos 2 omega t will become sin 2 omega t upon 2. So after further simplification, you will find out that this is the formula. Please note down this formula. V out RMS. So it will be Vm square into pi minus alpha divided by 2 pi plus sin 2 alpha divided by 4 pi. The whole raised to half. RMS value of the output voltage. And what will be I out RMS? I out RMS upon R. Okay? Quickly write it so that we will solve a numerical. Write down the statement of the numerical over here. Everyone. A single phase semi-converter is operated from, quickly, a single phase semi-converter is operated from 120 volt 50 hertz AC supply. 120 volt 50 hertz AC supply. The load resistance is 10 ohms. This means it is a semi-converter with a R load, resistive load. Now further, if the average output voltage is 25% of the maximum possible average voltage, determine firing angle. Then B part, RMS and average output current. RMS and average output current. This is not straightforward. You have to think a little. A single phase semi-converter is operated from 120 volt 50 hertz AC supply. The load resistance is 10 ohms. If the average output voltage is 25% of the maximum possible average voltage, determine firing angle, matlab alpha you have to determine. Secondly, RMS and average output current. So over here, you have to first find alpha, and what you have to find? I out RMS and I out average. Correct? So how will you start? Sorry? So where do you get maximum possible average voltage? Abhi V out average value kitna hai? What is the expression? Vm upon pi 1 plus cos alpha. Where will you get maximum output? Average value. When alpha is 0. Right? Everyone agrees? So that's what the starting point is. First of all, write the given data. V in RMS is 120. So what will be Vm? 120 root 2. Are you all following? See, you should understand. You just not sit there and listen. If you are not following, please ask. So for a single phase semi-converter, V out average is Vm upon pi 1 plus cos alpha. They are asking, they are telling us that maximum average value kabhi milega when alpha is 0. Cos 0 is 1, right? So it will be like, 2 Vm by pi. So whenever alpha is 0, V out max value is 2 Vm by pi. Abhi what they are saying is in the numerical, average output voltage is 25% maximum average value. That means V out average is 25% of maximum value. मतलब 25% means 25 by 100 into 2 Vm by pi. So calculate V out average. Are you following the statement? So V out average will be 25% of V out average maximum, and V out average maximum is 2 Vm by pi. Alpha इसमें हटा ही नहीं है. Actually we have to calculate alpha. So 25% means 1 upon 4, 2 Vm. Vm is root 2 times 120 divided by pi. Please check whether the value is 27 or no. 27? So good. Now what is the formula for V out average? Vm by pi 1 plus cos alpha. So from here what is unknown? V out average is known, Vm is known, alpha is unknown. So calculate alpha. Please calculate alpha and let me know the value of firing angle alpha. I hope everyone is carrying a calculator and doing your own calculations. Do not just write the value, you have to solve it and get it on your own. Everyone got V out average as 27 volt? Yes? नहीं किया? 27, okay. Completed? Okay. So calculate the value of alpha and let me know what's the value. 120 degrees. अल्फा का रेंज क्या है? कैन इट बी एनी वैल्यू और बिटवीन समथिंग 0 to 180 बीच में आएगा? इफ यू आर गेटिंग एनीथिंग वियर्ड देन इट्स रॉन्ग. Alpha is coming out to be 120. Yes. You see, alpha is 120 greater than 90. Still, the output average value is positive. तो सेमी कन्वर्टर में आउटपुट वोल्टेज नेगेटिव जाता ही नहीं है, पॉजिटिव ही रहता है. एंड आयोड आल्सो इज पॉजिटिव. सो पावर फ्लो इज ऑलवेज फ्रॉम सोर्स टू लोड in semiconductor, and that's why it is called as a one quadrant converter. Completed? After this, what do? You know the formula for V out RMS, V out average. So calculate I out average. What is I out average formula? V out average upon R, and R value is 10. So go ahead and calculate I out average and R. Acha, what will be I out average? Please calculate. Here I have calculated I out RMS first. So that will be V out RMS upon R. Remember, in pi minus alpha in the formula, alpha is in radians. So 120 degree you have to convert into radians. That will be 2 pi by 3. Yes? So be very, very careful with the calculations. Here I am showing this. Why it is sine 240 degrees? It is sine 2 alpha. Alpha is 120. वो Vm square भी अंदर था ना, तो बाहर निकल गया तो Vm हो गया, right? Vm square was inside that half. What's the value of I out RMS? Anyone? Is it 5.306? Check. What about I out? I out average is very, very tough. What's the value? V out average upon R, and V out average was 27, right? Yeah, 27. And what's the value of R? 10, na? So it's 2.7. Sorry? Are you all getting these answers on your own with your calculator? I out RMS is 5.3 amperes. Please confirm. Unless and until you get confidence of getting the answers with your own calculator, it will not work, even if you know the formulas. So you have straightforward I out RMS formula, all the terms are given. Alpha is there, VM is there, you have to just calculate. So I out RMS is coming out to be 5.3 amperes and I out average is coming out to be 2.7 amperes. All of you all got this? So almost time up. We'll stop over here. And in tomorrow's class, very, very crucial, we are going to cover semi-converter with RL load, RLE load, and also possibly we'll see the performance parameters of semi-converters. Okay? So that's it for today. Tomorrow we'll continue.